Quick intro to Unity. The first thing you need to do is install Unity. I'm going to assume you have already done this and also installed the Visual Studio. I'm also going to assume that you are using the Unity Hub, which is this window that I have open here. If you do not have the Unity Hub, you can download it in the Unity website. So once you have the Unity Hub, you go here to this Projects tab, and creating a new project is very simple. You click where it says New Project, and for now, we are just going to kind of ignore all this template stuff. There are different templates that come with pre-configured settings and stuff like that. We're just going to go with a very basic 3D template. Here we have the project name, which you can call it whatever you want. And here you can choose a location to store it in. I'm not going to create a project. This takes a little bit of time. It always takes like 5 minutes to create a new project. I have already an empty project that I created, which is this one. And this is how it's probably going to look like for you. It might look a little bit different because you might be using a different Unity version, and you can see that version here at the top. When you create your project, you can choose a different version to use. I'm using, in this case, 2021.2.7, and different versions might have slightly different UI and slightly different sort of default UI. But if you are using this same version, 2021.2.7, it will look like this. So first thing that I want to bring to your attention is what's sort of in the middle of my screen, which is the scene view. This is our 3D view where we will build our game, and you can think of this as our level. So everything that we will see in the game will be visible here. First of all, about the scene view is that we can move around it. We can right click and I cannot. Oh, shit. Is that I can. The first thing about the scene view is that I can right click and rotate my view here. And I can middle click and pan the view like that. And I can also zoom in and out with the mouse wheel. Another thing I can do is use the WASD controls to move the camera as like in a first-person shooter, basically, right? So I can, first of all, I need to right-click, and while I'm right-clicking, I can move the view with WASD. I can use E to go up and Q to go down, right? And so I can just navigate this like in a first-person perspective, and I can rotate the camera at the same time, and so on and so forth. So this is my scene view. Of course, right now it's empty, but we could add some objects. How do we do this? First of all, I need to talk about the hierarchy. So on the left of the scene view, there's this hierarchy tab, and this is basically showing us all the objects that are in our scene. Right now we have two objects. We have this main camera and this directional light. If you click any of them, you will see the scene view shows you where this object is. And it has these little arrows, and these arrows allow you to move the object. So you can move this object around. Right now I'm selecting the camera. This is not the camera that is showing the scene view. This is the camera that will show your game. So when the player is playing the game and moving their character around and stuff, this camera determines what they can see. We will talk more about this later. Next thing we have is the directional light. So this is just a default light that lights up our scene. Otherwise the scene would be very dark. Okay, if I want to add another object here, I can either go to this plus icon at the top of the hierarchy here, or I can right click in the hierarchy itself And for now, let's just go here to 3D object and add a cube. So I just have like a basic cube here. And like I said before, we can navigate here on the scene view, move around, pan, rotate, and we can move this cube around. So I can put it here. Let's put it near the camera so that the camera can see it when we run the game. So we do something like this. Okay. This is the basics of the scene and the hierarchy. Now I've put this cube next to the camera. If I click on the camera, we see a preview here on the bottom right. This is what the camera is currently seeing. And if I move the camera, you see that the view changes, right? So you can do that. I can not only move the camera, but I can also rotate the camera. And for that, I use these tools here to manipulate my currently selected object. This is rotate, and there's a shortcut as well, which is E. And I can scale and do these other things that we don't need to discuss for now. This transform tool, it basically shows me all the operations at once. So I can move, I can rotate, and I can scale all at once. Control Z to undo. But for now, I can just rotate, and I can rotate the camera, for instance, to get a more top-down perspective, and I can move it up a little bit like that. So now you can see there's this sort of pyramid shape coming out of the camera. It's not really a pyramid, it's a frustum. And this is what the camera is seeing, and you can see there the perspective is also changing. I can rotate the camera like that, and you see what happens to the preview. It's obviously like rotating around and stuff like that. I can go to the cube, I can do the same. I can rotate the cube, right? Can rotate it around like that. So if you click on one of these axes, one of these like colored circles, then it rotates just in one direction. But if you click sort of in the middle of the cube, then you can rotate in every direction at once, and it just follows sort of the direction of your mouse. Okay, so we have this cube. I'm going to just revert it. And we can also scale it, so that's the next tool. The shortcut for scale is R. And it might be a bit confusing that R is for scale and not for rotate, but it makes sense because these shortcuts are assigned to Q, W, E, R, T, Y, and this doesn't have a shortcut. So just remember that these are following the top row of the keyboard. Basically these tools here, you can also move this around if you want to. So R is for scale, and when you scale, same thing, you can scale in like one axis only, or you can click here in the middle and you scale in every direction at once. So we can resize our cube, make it a little bit, I don't know, like that. Doesn't matter too much for now. And if I click on the camera, I can see that preview. And yeah, that's how my cube will look like when I run the game. Now, how do I run the game? I go here to the top of my scene, of my window, and there's this play button. I can click it. There's usually like a short loading bar, and there it is. That's my game. Right now, obviously nothing happens because I didn't program any behaviors, any interactions. So it's just like a static camera, doesn't move, and there's my cube or my, wall shape that I made. And notice that this screen is showing me exactly what that camera preview was showing. And sometimes it's very useful to be able to see this without having to select the camera, because let's say that I want to move this cube. I want this cube to be in the camera shot, or maybe I have two cubes, or I have like a a sphere, let's say I'm going to add a sphere here, and I want to move it here, and I want to make sure that it is visible, that the camera can see it. I would need to select the camera. Okay, it is visible, and maybe I want to put it a little bit more to the side, and I want to see how it looks like in sort of the final shot. It's very tedious. So one thing that I really strongly recommend is that you look here at the scene view. There's this scene tab, let's say. Next to it, there's a game tab, right? If I click on here, you see the view of the camera. This game tab shows you what the player will see, right? It shows you the same thing that the camera shows you, but without having to click the camera. Right now, these two tabs are next to each other, so you either see the scene or the game. I consider this to be really, really bad. You want to see them both at the same time, at all times. Please, please do this, because otherwise you will be doing stuff in the scene view that will look bad or will break your whole game view, basically. Things will not look like you want them to. You will be moving stuff around here, and then when you notice, oh wait, actually in the game view it looks terrible, right? So just drag this around. Like, you can drag this from this tab, drag it out, you can drop it here, and then it's like a floating window, or you can dock it. I recommend that you dock it either to one side of the scene view or under it, something like this, or you can also put it like that, something like this, or whatever you like to do, but that you see it somewhere. It's also very useful for when you're playing the game. Let's say that now I am playing the game, so I pressed play, right? Now I'm playing the game. We can imagine that something would be happening, right? They can move around, and my character is jumping around, and there's stuff happening. I can now very easily come to the scene view and move stuff around and see how that affects the game, right? Because now I can see both at the same time, and I can manipulate things here in the scene view, and it is immediately reflected in the game view while I'm playing the game, while things are happening in the game. So that's very important. Now, before I stop playing, I would like to point out another thing. I just changed my scene, right? I moved this sphere and I rotated this cube and all this stuff. Now I'm going to stop the game. I click here on play, on the play button, and everything went back. Everything was reset to the original position before I played the game. This is another very important point. All the changes that you do to the scene while you are in play mode, while you are playing the game, will be reset. They will not be saved. So if you want to make changes to the scene that should be permanent, then you need to do this in the so-called edit mode and not in play mode. So while you are not playing the game. Otherwise, they will not be saved. This is, on the other hand, very useful because you can go into play mode, you can move stuff around, you can mess with stuff, or mess with this, right? If you just want to experiment and see what it would look like, but if you then want to, if you're not happy with this and you want to revert everything, that's very easy. You don't need to click undo 20 million times. You just stop playing, everything goes back to the start. Okay, so that is the basic idea of the layout and the scene hierarchy and game. Now, the next thing that we need to look at is the inspector, which is this tab that is on the right side. And if I click on any object, the inspector shows me basically the properties of this object, right? So the first thing to notice is that these objects are all sort of divided into different sections. At the top, we have the name of the object. And of course, we can change it here. So I can call it, call this one a ball. And if you look now to the hierarchy on the left side, the name has changed there too. Going back to the inspector, we have tags and layers and stuff like this. It's not so important for now. Then the first thing that we have at the top is called a transform. This transform is what stores the position, rotation, and scale of the object. And every single object in Unity has a transform component. You cannot have an object in the scene that does not have a transform, because a scene is sort of like a physical space. If you have an object in the scene, it needs to have a physical representation, let's say. It needs to have a position and a rotation and a scale, okay? So if I make even an empty object, I'm going to go here to the hierarchy, right-click, create empty, and just call it empty. You see on the inspector, it has nothing else except the transform, because it must have a transform. And you see here in the scene view, it still has a position. I can move it around, and you see the numbers in the transform component are changing. I'm moving it around and that position changes. I can also change the numbers directly. Instead of doing it here in the scene, let's say that I want to put this object in a very specific position. I want to place it at position 2.8, 0 and -1. Boom, there it is. It is specifically in that position. And of course, I can do that for the other ones. Let's say that I want this cube to have a certain scale, right? If, let's say, I'm making walls and a level, I don't want the walls to have a size of 1.583724, because maybe then they don't fit with each other, you know, like you try to make the walls fit and there's always like a little bit sticking out and stuff. So we just make them all like whole numbers, or, you know, round numbers sort of. So that's very practical. Another interesting thing to know about the transform is that you can right click it and click reset, and this makes the position and the rotation 0, 0, 0 and the scale 1. So it just resets the all the values to like the original values. I'm going to undo this, however. And now let's look at the other things that are here. So this cube has some other things in here. Each of these that can also be collapsed and expanded, each of these is called a component. And each of these has some behavior. So this cube has a few components besides the transform. It has the mesh filter. This is what tells Unity what 3D mesh or 3D model should be drawn in this to represent this object. If I would remove this, or if I would change here this mesh cube, if I change this by clicking here on this little circle, and I click here, make it like a cylinder. Now it's a cylinder. It's a little bit deformed, but it's a cylinder. Yeah, I can simply change the mesh here. Now that's a sphere, and so on. The second component is the mesh renderer. This is what actually renders, meaning draws the cube on the screen. And as you see, there are also some different options here, like lighting and shadows and stuff like that. So this is a component whose job is to take this mesh from the mesh filter, apply these settings, like does it cast shadows, does it receive shadows, does it get affected by light probes and stuff like this, which you don't need to know what that means for now, but basically takes all these settings and draws that mesh with these settings and with the materials, which is also an important thing. And last but not least, we have this box collider. The collider is going to be important for physics and for detecting collisions between objects. So detecting whether two objects are hitting each other, basically. Okay, so we have a scene that we see here in the hierarchy. Each scene has many objects, and each object has many components, right? That's the basic structure of a Unity project. Another thing is that each object can have children object, or you can think of it as sub-objects. So I can go to this cube here, or let's go to the sphere, and I can add a child. So I can right-click on this ball, and I can go here 3D object, and I'm going to add a cylinder. And so I get this cylinder. I'm going to scale it down a little bit and maybe put it like here on top of the sphere. And now if you notice the hierarchy, this cylinder is a little bit indented, and it's sort of like inside of the ball. And there's also now this little arrow that allows me to collapse and expand this ball. So the cylinder, we would say, is a child of the ball. What does that mean? It means that it will inherit some properties of the ball. Notably, it inherits the transform. So basically, if now I move the ball, it moves the cylinder with it. Because now what's going to happen is that Unity looks at this position and rotation and scale of the cylinder, of the child, and basically is going to add it to the position of the sphere. So I can also move it around, like for instance, like that. And now if I move the sphere, we still keep the same behavior. And you see the offset is kept. And if I rotate the sphere, I'm rotating the cylinder as well, keeping that offset. Okay. And if I click on the cylinder, you see that its rotation hasn't actually changed. But this is not really true. Of course, its rotation is changed because now it's like pointing down and stuff. But what this really means, what this 0, 0, 0 means, is that it is not adding any rotation to the parent rotation. Basically, it's taking the parent rotation, which is -8, -47, -144 degrees, and is adding 0 degrees. And it's doing the same for the position. If I would put the position at 0, 0, 0, actually 0 like this, you don't see it. If I would do it like this, and now I move the ball a lot, I move the ball around, like put it there, right? The position of the cylinder is still 0, 0.50. And obviously that's not true. That's not what the global position is, but that's where the local position is. So there's this idea of the global position, or you could also call it the world position, and the local position. The global position or world position is sort of the absolute position in the world, in the scene, from the center of the scene. And the local position is in relation to the parent. All right. And all that is happening is taking the global position of the parent and adding these values to that global position. And in the case of the scale, it's not adding, but multiplying, right? Because we're not adding 0.2 to the scale. That would be 1.2, but rather multiplying. So if I would scale the parent up and down, we still keep that same sort of proportion to the child. So I can make the parent very small, but the child will be even smaller because it keeps the same proportion, right? So it's basically the size of the child is going to be this size, 0.043 times 0.2. So it's even smaller. Okay, going to reset this. And so now it's in the center, right? This is the center of the world, basically, 0, 0, 0. Now, we have a game supposedly we have a video game. That's what Unity is used for, but actually nothing happens when I click in the play button. So let's make something happen. How do we do this? The first idea that is important to know is that we need to use components to add behavior to an object, right? So everything that will happen to any object in this scene needs to be driven by a component that we can add to an object. So to add a component, obviously we have this add component button, and if I just show you this list, this is a list of built-in components that come with Unity, right? So we have like audio components if you want to play audio, and effects and all this stuff, meshes and physics, you know, like these colliders and stuff like that. There's all this stuff, right? But if we want to, let's say, move an object when the user presses a key, then there is no built-in component for that. We need to program this ourselves. Now, how do we do this? That's what we will see now. First thing that we need to do is create a component. We need to create a new component. How do we do that? We need to create a file to hold this component. So to create a file, we are going to look at this other window, which is sort of the only window that we have not looked at yet, which is the project window. And in the project window, we see here on the left side, there's these favorites we can ignore for now. And then we have assets and packages. We can ignore the packages folder. We are just going to look at the assets folder, and you will always see like people talk about the assets folder and so on. The assets folder is where all the files that will be in your game need to be. They must be in the assets folder to be in your game. If they're not in the assets folder, then they're not in your game. They don't count. Okay? That's also why you only see this assets folder here in this project. If I would show you here in the Windows Explorer what this folder looks like, this is my project. This is my Unity project. This is the whole project, right? So it has the assets folder and the packages folder, right? These two that you see there. But then it has all this other stuff, right? But you do not see these other things in here because they are not relevant to the actual game. They are relevant just to the project in Unity, right? When you actually export your game for a player to play, they will not see any of these other things. They will only see the assets folder. Okay, so that's the first thing. We have already a folder here called scenes, and it has this scene file. That's the scene that we are editing right now, that we have open. And I'm just going to go here to the assets and right click, and at the top you see there's a create sort of menu, and then there's a lot of stuff, and the first one is folder. I'm going to create a new folder. I'm going to call it code and go into this folder, and now I'm going to right click, create C# script. You will also see in many tutorials people call this folder scripts instead of code, because in Unity, these components, the component that we are going to create is usually referred to as a script, and that's okay. I like to be more specific and call it code, because we're going to write code. Not all code files are scripts, because we can also have code that is not for components. So this just is a little bit more meaningful to me. Now we created this C# script. You see, we create a file. We can call it something. I'm just going to call this move or movement. And so now our file is created. Unity needs to do some stuff here. Okay, now I can open this file, and it will open a Visual Studio window. And hopefully opens the code here. So we have like basically a template for this code. This is, in my opinion, not a very nice template, but it's okay. We can adjust it in the future. So as you see, there is a public class movement, and very important, it inherits here from some class. This is a Unity class, and this is necessary to be able to make a component. If you make a class that does not inherit from monobehavior, then you have not made a component. This is not a component. This is a component. This is not a component. That's the difference. So we want to make a component. So we will leave it as a monobehavior like this. And now in here, we have two functions that come by default with this template. The first one is the start function, and you see there's a description here. Start is called before the first frame update, so you can think of it as a sort of like a constructor, you know, an initialization function. So if you want to set up your component with some default variables and stuff like that, then you can do it here in the start function. And then we have the update function, and it says update is called once per frame. So basically, once every frame, and the frame is basically 1 unit of time in your game. So the computer is running all these update functions as fast as it can. So it goes through all the objects that are in your scene and all the components in your scene, calls update once on all of them, on each of them, and that's 1 frame, and then renders the result, draws it on the screen. Then it goes back and calls all the updates again, all over again, gets the result, draws it on the screen again, and so on and so forth. And it does this forever until you close the game, basically. So let's go to here to the start method, and let's just do a very simple thing. Let's write debug.log start, and this debug.log is basically our basic print function, our console.writeLine, you know, that we know from the console apps in C#. And this will log this message to the console, to the Unity console. We will see what that looks like in a second. And now in the update method, we are going to do the same, debug.log update. If I go to Unity now, it should refresh, do something like that. And now, if I look on the right side to the inspector, when I click on this movement file, the inspector shows me the code. It shows me the text that's in this file. Okay, this is very useful for you to see if the code was actually imported into Unity, because sometimes it fails, sometimes Unity fails at this and because of some error or whatever, and then you can confirm, or you can check if the code is actually there from Unity's perspective, let's say. Okay, now if I run the project at this time, nothing will happen still. Nothing happens. And there's this console window here next to the project. I can click on it, and there's nothing there. We are not printing anything to the console. The reason is that even though we have created this code file, we're not actually using it. Because like I said, everything that happens in your game needs to be driven by a component that is part of an object. So I can go here to my ball, and I can now assign this component, or I can add this component to this game object, to this ball object. There are several ways of doing this. One way of doing it is I can drag this into the hierarchy and drop it there. Boop. And now you see in the inspector, it appeared there. I'm going to remove it, like right click on the component and remove. Another way is I drag this and I drop it in the scene view. I drop it on the object and you see it appears again. This one is a bit fiddly because once you have a big scene with lots of objects, this is not so practical. You need to like be very accurate to drop it on the exact object that you want. Like here, I could also very easily drop it onto the cylinder, right? So now it's like in the cylinder there. That's not what I wanted, right? I can also drag it and drop it in the inspector, boop. Or I can click here in add component, and now it will show me components that already exist in my project, and I will find them here under scripts. So I click on scripts, and then it shows me there my movement script. Okay, I can also search here. So when I click add component, I can search for movement and add the script like this. So there's many ways, and as you will see, there are also ways of doing everything else, and they're all very similar. Like when you want to add or assign something to a game object, you can often do it in multiple ways. Okay, so now I have this component in this game object, and when I play the game and I go to my console, we see that now there's something happening. Okay, so I'm going to stop the game and just see what is happening. I have a huge spam. I have 582 messages. I'm going to scroll up to the top, and the first message should be start. So we should see at first the start message and then a bunch of update messages. And that's because start, that we print here in the start method, it gets called only once when the scene starts or when this object is loaded. And then update gets called every frame. So we see like every time that the engine ran all the update methods, we printed this to the console. Okay, but this is still not very useful. I'm going to go back to my code and just going to remove this. And this is called movement, right? So how do we move things? First thing is to move something, we need to change its position. To change its position, we need to know about the transform, right? Because the position of the object is stored in the transform. So let's say I want to move this object on the x-axis. I need to do something like this, change the x-axis. So first thing I do is the following. I go to the update method because I want it to run every frame. I want the object to move continuously, not just to move once. If I did it in the start method, the object would move at the start just one time and then would stop. If I want it to move continuously, I want to do this in the update method. So first I need to refer to the transform. Now, a neat thing is that every component, because of this inheritance of the mono behavior, every component already has a built-in reference to the transformed component. And this is very simple. It's just the word transform, like that. With lowercase, not with uppercase. Uppercase is the type transform, and you see it gets colored in this blue-green color, but it's the lowercase transform. So transform, and now there is a very simple method that I can call. It's transform.translate. This is a method, and you see there's a description, moves the transform in the direction and distance of translation. So I can pass in some parameters. We see also there are 6 different overloads, and one of them is this one where we can pass an X, Y, and Z values, and it will move in those, that amount in each axis. Okay, so let's say that I wanted to move in the X axis, and I will just say like 1, 0, 0. So it will move 1 unit in the X, 0 in the Y, 0 in the Z, every frame. Okay, because it's in the update method. If I go back to Unity and reload, now I play the game, and I should be able to see that this object is moving. There it goes. I'm not doing anything. Hands off. And it's just moving. If I look at the inspector, while the object is selected, you see that the value is increasing forever. It will never stop increasing until, I don't know, your program crashes or whatever. Okay, so we make this sphere move. Great. How do we make it move now in a more sensible way? Because right now it's moving forever. A better way would be to move it when the user presses a key. So that's the next thing. How do we detect that the user pressed the key? Very simple. There's this class called input, and this input class gives us methods and variables that concern the user input, like the keyboard and the mouse, right? So the basic thing would be input.getKey down. So this this will return true. You see, it returns a bool. It says return true during the frame the user starts pressing down. So if I do this, and as a parameter I give it a key code, which is an enum, it's similar to this console key in the C# console. So I can go keycode.space or whatever. And remember that this returns a bool. So returns a bool if this key was pressed in this frame. And so I can put this in an if statement. So if this key was pressed in this frame, then I'm going to move the transform. That's it. Go back to Unity. Play again. And now, if I don't do anything, the object doesn't move. When I press space, it moves. See, it moves a little bit. You can look here at the game view as well, and you see it moves a little bit to the right. Tuk, 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 tuk. And in my scene view, it's moving sort of forward because you know, the camera is like here. So the camera is looking from this side, and I can press space and it moves. Okay, and from here you already have the basics of moving things, and you can already make like a character movement system. Of course, you just need to check for different keys and move in different directions. So if you press the up arrow or the W key or whatever, you move in one direction. If you press the S key, you move in the opposite direction. If you press the A or the D or the left, right arrows or buttons on the controller or whatever it is, then you move in a different direction, right? Like after this, it's just like extending this logic. And of course, probably changing this, because you probably don't want to always move in a fixed direction, but maybe like where the player is looking or where the object is rotated to and stuff. We will also cover this in the future. But for now, that's the basics, right? Like we got it more or less. Now, one thing that I will show you is that there are different types of this get key function. There's this get key down. Like I said, it is true only one time when you press down the key, and if you hold it, nothing happens. So it's just like you press it, it runs once. There's the get key up, which will be true when you release the key. And then there's get key. Get key is true all the time, like when you press it and if you keep it pressed. So if you hold down the key, get key will return true. And I can show you this. I will hold down the space bar and our object will keep moving. Now it moves. Now I stopped pressing. You see the value is 55. And if I press again a little bit, it moves a bit and moves a bit and moves a bit and so on. Okay, so that's the basics of input and movement. But now one thing that you might notice is that we are moving very fast, right? So we could slow it down. We could slow our character down by going here and changing this from 1 to like 0.1. So it will move 10 times slower. But another thing that we could also do is, instead of changing the code every time, it's not so nice. It's a little bit annoying. What we can do is we can make a variable, and then we can change this variable. Let me show you. I go here to the top of my class, and I'm just going to make a public float speed. Okay, and now I'm going to use this speed. Let me make it 1 by default. So this will be like a default value for the variable instead of 0, which would be the normal default value for a float. And now, instead of using just the 1, I'm going to use whatever value is in this variable. And now the cool thing is that if I change to Unity and I have this object selected, when I look at the inspector under this movement script, there it is, the speed. I can see this variable there, and I can change its value. I can either drag here, or I can type whatever value I want. So let's say Let's go with 0.1. Play the game. A shortcut for playing is Control P. And now I can press the spacebar and look, it moves much, much slower. And I can even make it negative, and now it will go in the opposite direction, right? And I can make it like 0, 0, 1, and now it will move very slowly. Maybe 0, 1, yeah, 0.01, or I don't know, 0.05. Yeah, and of course I can make it move very fast. Boom, it just disappeared because why? It moved 50 units in one frame. Just for you to have an idea of how much 1 unit is. Now the sphere is at position 0, 0, 0, right? The x equals 0. Now I change it to 1. Boom, that's how much 1 unit is. So when I say here, hey, move 1, it means move 1 unit, 1 unit. So in one frame, it will move, let me go here, it will move this much, yeah? What I did there is I duplicated this object, and duplicating is can be done with Control D. And yeah, so just duplicated this object and put it at 0. So this is 1 unit of distance, right? Okay. And last but not least, we should talk about some other things regarding this Unity, what are called the Unity messages. So you see like the start, there's this start, and it says, Visual Studio says here, Unity message, and there's an update, and there are more. There are tons of these messages. There are so many. The first one that is nice to know is awake. Awake is a little bit like start, but it is called before start. So there's like 2 steps, right? There's the awake, gets called first, and then start. There are some other ones. There's on enable. This is when you enable or disable this component, which is doing this here. So if you do this, this is on enable gets called. You disable it here. There's also an on disable. So then on disable gets called, and you enable this component again, on enable gets called, or you can enable and disable the whole object. So if I go here to the game object itself, you see at the top next to the name there's a checkbox. I can disable it, and now you see that the object disappeared from the scene. Why did it disappear? Because disabling the object, it's still there, but disabling it means that all of these components are disabled. It's the same as doing this. You see, the result is basically the same. And also one thing that it also does is it also disables the children, because right now these things are disabled, but you still see the cylinder. So actually we wouldn't also disable the cylinder. Now we have disabled the game object essentially. So basically disabling the game object completely is the same as disabling each of the components and the components of the children. So when you would enable and disable the game object, this would call the on enable and on disable methods. And there are others. There's on destroy. So when the object is destroyed, like if you would go here and delete it, boop, the on destroy method would be called. And there's tons of others. Most of them start with on, and you see there's here like a huge list of them, but there are also other functions, and there's like a whole thing about when each function gets called and so on and so forth. You can consult the Unity documentation about this, but it's very useful to know that there are all these things, and of course you can sometimes do a lot of complicated things, let's say, just by exploiting these Unity messages. Okay. Last thing is more of a sort of a preference, which is that if you are running the game you might have noticed that when you change the code, I think by default, Unity will reload the scene. Because you change the code, Unity will reload the code. It notices that your code has changed, and then it kind of like reloads the scene. And ideally, this works very well, and the changes that you did in the code are then immediately reflected in the game. But in practice, this does not work. And not only does it not work, but it will cause you huge headaches. It will make it so that you change the code and then Unity tries to reload the code, reload the scene and blah, blah, blah. But then it doesn't work because now, of course, obviously, your code changed and something that was happening before you changed the code now is not there anymore in the code. Like you remove the line or whatever, and now Unity thinks that this thing should happen, but doesn't happen anymore, and then your whole game breaks. Also, if like you will break references, scripts that were referencing other scripts and stuff like that, like they will all be broken. So this doesn't really work. This will cause you way more trouble than it's worth. So I recommend very strongly to disable this. How do you disable this? You go to Edit, Preferences. Now in general, at the top, you see there's a couple of options. There's basically two things that are important. The first thing is this here, script changes while playing. You have several options. First one is recompile and continue playing. So this is what I have, but this only works, this is the default, but this only really works in conjunction with something else. Then we have recompile after finished playing. This means that if you change the code while you are playing, Unity will not recompile, it will not reload the scripts, it will not reload the scene, it will not do anything until you finish playing. So when you exit play mode, then it will refresh everything. And the last one is stop playing and recompile. So this will, you change this, the code or whatever, Unity automatically stops the play mode and recompiles. I really think this is very bad. You definitely don't want this. But I would recommend one of the two. So either you have this plus the second option that I will show you, or you just have this one so that Unity does not break your whole game while you are playing. So I'm using this. And like I said, you can use this in conjunction with another option, which is here under Asset Pipeline. Auto refresh is the first one. By default, it will be enabled. And that's the problem, that this thing is enabled. It auto refreshes your project. So it detects that something has changed, refreshes, and then it recompiles while you are playing, recompile and continue playing. This is what you don't want. So either you have this, but you turn off auto refresh. This is what I have. Or you keep auto refresh on and you recompile after finished playing. So these are the two options that I strongly recommend. Now, if you have auto refresh turned off, how do you refresh if it's not automatic? Very simple. You press Ctrl R, or you can go here, right click anywhere, and you click refresh. Right? So you see the shortcut is Ctrl R. So when you make a change here, like let's say I will make a change, I will make another variable. Okay, I change to Unity, nothing is happening. If I click here on this code file, you see there on the right side, it does not show me the foo because it has not refreshed. Now I will press Ctrl R. There it is, my foo. Yeah, that's it. So that was it. That's the Unity introduction. Very brief, short and to the point. Of course, it is going on like 50 minutes, but it really is just a very, 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 very tip of the iceberg. Unity is huge. There's a lot to talk about. This is just a very, very quick introduction that allows you to already start. You can make things move. You can detect object user input. You can create components. You can add components. You can create game objects, and so on and so forth. Thank you, and see you in the next video.